All right, so we're getting into chapter 9, lesson 2. We're dealing with a couple new words of input and output. Things we actually talked about a week and a half ago, and I said those really should be easy words to understand because we know what going in means and we know what going out means. So if I put something in, something's going to come out, right? If I put in flour and sugar and egg and milk into a bowl and I mix them all together, and then I add heat, so I put things in, what comes out after I add heat? I get a cake. So I know that if my input is what goes into it, my output comes out. Not difficult words. In all honesty, neither are the terminologies of dependent and independent. They're very logical. Yesterday's lesson was designed to be one of the easiest lessons we've done since Christmas break. Should have been a bing, bang, boom, I'm done, I'm finished, I have extra time to do work. But some of you heard big words, saw big words, and your brains went, blah, I can't do it, it's too hard, it doesn't make any sense. Nonsense. You just have to put forth the effort. The idea of independent and dependent is not something new to your life. You depend on your mom and dad for everything. You depend on them for a house. You depend on them for a bed. You depend on them for clothes. You depend on them for food. You depend on them making sure you get to school and back from school. And some of you depend on them for help with your school work. They do it all for you. They are independent. They do it on their own. They do the work. When I look at math, it's the same way. The dependent is just waiting for everything else to be done. The work is independent inside. My math, my input is my independent. It's where the work is being done. My output is waiting outside for it to be done. It's my dependent. We have done charts like this for several months now. Since the beginning of school, when we did ratios and we did units and we did unit rates, it's the same thing. So we're just going to put all this information together and do some thinking to get to some final answers. I'm going to take whatever it tells me my x is and I'm going to input it into a rule. Whatever the process is, whatever the rule is, I don't know. But it's going to mix it up and we're going to get an output. I'm going to be told that my x is equal to 3. And if my x is equal to 3, then what is going to be done to it? What is the process? That's my rule. If my rule says that x times 2 minus 1, and I know that my x is 3, I substitute in. Some of you are still saying, well, I don't understand substitute. Have we had to substitute this year? Several times, right? With my meetings and things. And what does my substitute do? They come in and they take my place and they get you through the lessons that I prepared for you for the day. They're taking my place. When I know that x is equal to 3, I substitute it in. I put my 3 in place of the x. And then we get through the day. We do the process, we do the work. And when I do the work and I substitute my 3 in, that's going to give me my output. That's my y, my final answer, my dependent variable. I'm going to take y is equal to 3 times 2 now, because I know I have to multiply before I add and subtract. And I have 6 minus 1, and therefore my y would have to be equal to 5. Now, you might be saying, well, this isn't in my book. You're right. But you could always pause the video and take some notes in all of the spaces that it provides you so that you have it written down and have something to look at. Just a suggestion. Here's my scenario that we start with. Talking about inputs and outputs. What is dependent? What is independent? I have skating charges of $3 for each hour of skating, plus $1.75 to rent my skates. Write an equation. We have been writing equations and expressions and show me what this thinks since before Christmas break. When I read the problem, what does it mean? Well, some of you still kind of get tripped up by words. Maybe you look at plus and you don't know. Or you look at for each and you're like, I don't know what that means mathematically. Well, your teacher did you a favor. And he saved a document for you a couple weeks ago on Canvas that will let you go through what all of these terminologies mean mathematically. If you remember, there was a multiplication sign and all the different words that could indicate multiplication. And there was an addition sign and all the different wordings that could mean addition. And some of you have never opened that document one time, but you come to me and say, well, I don't know what this means. Where's the effort, my friends? I put the effort forward to get the document for you and to make sure it had the words that we use. I took the time to find it, and then I saved it to give you access. Where's your effort? Put it forth. Things become a lot easier. So let's look at what they asked me to do with this information then. They asked me to identify what my input is going to be, what my independent variable, where the work is being done, to get to my output, which is my dependent, my answer. So when I find that I know that my cost is, my total cost is, then that's where my equal sign is, and that's going to be my y. That's going to be my dependent. That is going to be my output. And therefore the work has to be where my input is. It is my independent variable and what's being done to it. So I begin to build it. Now, you can start with y is equal to, or you can just put it on the right hand side, which is how you've seen most math problems since you were in first and second grade. It doesn't matter because it doesn't change the math that's done. You can put is equal to y, that's fine. But what matters is that I have the next part set up correctly. I know that for every hour that I skate, I'm going to pay $3. Now, it doesn't matter if I put h times $3 or $3 times h, because multiplication can be done in any order, addition can be done in any order. That's our properties in mathematics, and we know it doesn't change the answer. But then I know I have to add $1.75. When I know that's my rule, then I can do it for 14 hours and show the answers for every hour for 14 hours if I want to. Well, we don't want to, we only want to do 4, which is what's down below on your paper. So if this is my rule, we check our work and make sure we got the right rule. We did, because that's what this says. Well, I have an H though. That doesn't matter. They tell you that my input is going to be in time or hours, but I still just show it as an X. So where we have $3 times H, they just have 3 times X. It doesn't matter what letter I use. It matters that I do my work correctly. And then I see that each time on this one, I have to build the rule, build the rule, build the rule, using that substitution method, because if I don't show that, I miss a point, which is really silly. And then I'm going to show work, so I get another point. And then I'll put my answer, my dependent variable, my output of what y is equal to. So when I do this one, it's done for me. So if I just go to the second one, I know I'm going to take my x and I'm going to substitute it in where the x is, or it's the same as where the h is in what we originally wrote. So I write out my rule. So now I have 3 times 2, because it tells me to use 2 instead of an x, plus the $1.75. And I write it down on my paper, and I show work. So I know that 3 times 2 is 6, and then I have the adding of $1.75. And when I add $6 to $1.75, 6 plus 1 is just simply 7, and I'm left with 75 cents. I showed my work. Now, your boxes are pretty small, I understand. This is enlarged quite a bit. I had to make really small typing to fit in there when I was doing it on my computer. You have plenty of space on your paper, or you get a separate sheet of paper. You can use some of my computer paper if you need that. You don't have line paper, I'm fine with that. But show your work so you get credit. For 3 as my x, my input, my independent variable, I plug it in for 3. I have $3 now times 3. 3 times 3. Third grade math. 3 times 3 is 9. 9 plus $1.75. Well, 9 plus $1.75, second grade math, introduced to decimals. I line them up, and I know that 9 plus 1 is 10, and I'm left with 75 cents. So now I have my answer of $10.75. I substitute again. I substitute 4 for my h. I want you to do that one. Pause the video, fill in the last two steps, unpause. So if you follow directions, you now have two answers here. You showed that substituting my 4 in for my independent variable was 3 times 4 and plus my $1.75. And then you showed the step that you multiplied first, order of operations, multiplication and division, before addition and subtraction. And then I add $12 and $1.75, and you got the answer of $13.75. So, moving on. Here's my next thing. I have this big chart. I have Jamal. What is Jamal doing? Jamal is downloading songs. How long does it take him to download a song? Well, it depends on how big the song is. Well, how big the song is measured in megabytes. This word is megabytes. You often see megabytes as MB or gigabytes as GB. But what we want to know is how long is it going to take to save it to my MP3 player. So I set up my chart that they give me. They show me it this way. And generally when we do ratio charts, we do them long ways. So instead of vertical, we're going to go horizontal. And then when I start to look at it, I notice when I have my answer as a dependent variable that I suddenly have a 48, a 60, a 72. And when I have my independent variable where my work needs to be done, they threw in a 12. Well, I know that that dot means it's multiplication. Y is equal to x times n. My x is what they tell me it is. That's my independent variable. But I'm multiplying by n, a number. Well, where did that number even come from? Well, some of us, when I look at this chart, we know, oh, well, 4 times 12 is 48, and 5 times 12 is 60, and 6 times 12 is 72, and 8 times 12 is 96, and that's just in our head. But there are some of us, that is not in our head. And I'll be honest, it will depend on have I had coffee or not, if that's in my head. Because without coffee, I'm really tired and my brain doesn't like to think. So how can I find it if I don't automatically know? Well, we've been doing it for the last 3 weeks. We're going to do the opposite function on the opposite side. We did it before Christmas on several lessons when I first introduced it, and there was extra problems on the back when we got into geometry. I'm going to do the opposite function on the opposite side. Well, how do I do that then, Mr. B? Well, I'm going to plug in the information that they tell me. They tell me that my y is equal to 48, and then my x is equal to 4. And I have some missing number that I don't know. I'll pretend that it's not 12, and we'll see. Can we prove it? Well, how do I get rid of my 4? Well, it's pretty easy, because the opposite of multiplying by 4 is dividing. So I divide by 4, which cancels it out, and then I come over to the opposite side and I divide by 4. And 48 divided by 4 is what? Hey, it's 12, which is what they said it was. So what if they didn't tell me what it was? Can I just assume that when I find one answer, that that's it? Because see, when I first start these out and I look at it and I go from a smaller number to a bigger number, I always try multiplication. Always. But there's about 10% of the time that they do these that they try to trick you. Any math book does, any math program does, and they actually make an addition. So I want to make sure I'm right. So I have a hypothesis and I test it a second time. All right, so let's do what they tell us. If I have 5 for my x, and I have a final answer of 60 for my y, my input, my output, my independent variable, my dependent variable. Then I do my opposite function on the opposite side. I'm multiplying by 5, I'm going to divide by 5. Cancels out. I have dividing by 5 on the opposite side then. And 60 divided by 5 is, it's 12 as well. If I get the right answer 2 times in a row, then how do I prove that I'm correct? I do it 3 times, and I make sure. On the third one, they tell me that I have a 6 for my x, and that my output, my y, my dependent variable is 72. Opposite function on the opposite side. I divide by 6 since I'm multiplying. Cancels out. I go to the opposite side. 72 divided by 6. It is indeed 12. And if I wanted to, just for good measure, I could do the last one as well. They tell me that if I have 8 as my x, my input, that 72 is my output, my y. And 8 divided by 8, to get rid of it, is indeed going to give me my n. And 72 on the opposite side divided by 8 is indeed 12. So my 12 can be proven where it came from. This was, once again, the blue, my thinking process. But if I don't know how to get to that thinking process, it's a confusing process. So some of us just need to work it out, and that's fine. Please do. But what I'm proving is that y is going to be equal to, my output will be equal to 12 seconds times however many megabytes we're talking about. So my x, my input, is my megabytes. So if I know that then, and I know that my equation is y is equal to 12x, because that's going to be a first point on my homework assignment. I have to show the equation. Then I solve for my missing piece, and that would be my second point. And showing my work would be my third point. So if I plug in the information into the equation, and I know I'm looking for what if it was 7 seconds, because this one is blank, then I just plug in 7. Well, if y is equal to 12x, my independent variable, my changing in my work, and this is my answer relying upon it, I plug in my 7, and I take 12 times 7, so I know y is equal to 84. So I know it'll take Jamal 84 seconds to save that song. Going on. Practice problems. Wait, we only did 2, and now we're ready for our practice problems? Yeah, because this is really easy. This is really, truly nothing new. We have done these kind of charts when we call them ratio charts. Same thing. Although they were laid down instead of going up and down. That doesn't matter. Going horizontally or vertically doesn't change how I do my math. But I had information, and I didn't have to do anything other than just multiply it by, I'm going to have information, and I might multiply, I might divide. I could add or subtract, but on these examples I don't add or subtract. But you can see what I'm talking about. Okay? We'll solve for those, and I'll give you 2 hints to know how to do those. That's the easy part. They tell me my rule. Yeah, I have to write my rule on that one. I don't have to on there. So those of you that really don't like to put forth extra effort, they made it easier. You don't have to show 3 extra steps. But on these, I'm going to have 1 answer here, 1 answer here, 1 answer here, 1 answer here, and I'm going to show work. That's going to be worth 5 points. Over here, I'm going to have 1, 2, 3 answers, and work, which is 4 points. And down here, well, we'll talk about this when we get to it in just a second. So they tell me my rule. I know what my x is, and I'm just going to plug it in as my input each time. So if my rule is y is equal to, what is my y equal to? X plus 3. Then I'm going to do my substitution method. 1 is x equal to for the first one. Well, x is equal to 6, so I plug it in. I'm always going to look at this first chart. That's my input rule. That's going to tell me where to put it in. Now, we're going to look at the top chart when we get to the bottom questions. But I want to look at this first chart to find out my x. I plug it in, I substitute it in, and 6 plus 3 goes all the way back to first grade math. I can take 6 fingers, I can add 3 fingers to it, and I can get 9. I got that. 6 plus 3 is 9. Alright, so what about 8 and 3? Some of you need to take your shoes and socks off so you can use your toes, but I think you got it without doing it. Plug it in. I have y is equal to x plus 3. That's why that's there. I just simply add. 8 plus 3, 11. So we need 1 big toe. And then I'm going to substitute my 10 in. If I substitute my 10 in, that's going to be my first point. I have to show what the rule was that I solved for. So I just write it down. 1 second to write it down. That's it. That's all it needs. 10 plus 3, a couple extra toes, we end up with 13. So I got 5 points because I showed my work, I showed my rule that was left out, and I showed all of my outputs. I go to my second one on number 2. It gives me the rule. The rule is that y is equal to 2 times x. Once again, coefficient, variable, constant. Now, this is where some of you are really hurting yourselves when you watch me in fast forward or you only watch me solve one problem and you skip the rest of the video, I got this is easy. You miss a lot of the things that I review with you when I do these, and I give you extra hints and things to remember or to learn throughout the rest of the video. So stop skipping and stop watching and fast forward and just take the 30 minutes that I asked for on the videos. Coefficient, variable. Variable is a letter. Some people came to me, 2 people came to me yesterday and said, what is a variable? Because they didn't understand, well, what's an independent variable? What's a dependent variable? And I said, what's a variable? Well, I don't know. We've talked about variables since before Christmas. A variable is a letter. We ought to know that. But I've reviewed it in multiple videos, which means you're not watching my videos or your brain is not engaged with me. We're not thinking. We got to think. Moving on. So I'm going to plug in from my input box the information they tell me. So I'm going to plug it in and I will show the work. Plug it in, show the work, plug it in, show the work, and then make sure I put my out points over to the right. So I'm going to take my 4 and we'll plug it in. 2 times 4 plus 1. Order of operations on your papers. I usually write it O. If you've missed it, order of operations. 2 times 4 has to be done first. Multiplication and division from left to right before I do my addition and subtraction from left to right. 2 times 4 is 8. 8 plus 1 gives me 9. I know my y is equal to 9. I plug it into my chart. 2 points. It shows my work. I got my answer. Now I'm going to go back to my input box. I see a 7. And we'll plug it in. 2 times 7 plus 1. Just simply substitute it in. Multiplication first. 2 times 7 is 14. 14 plus 1 is 15. Y is equal to 15. If my input is 7, my output has to be 15. 2 points. I showed my work. I plugged it in. Substituting in for 10. Do it on your own. Pause the video if you need to. Come back to it. So hopefully you're going to get 2 points because you're going to have work and you're going to plug it in. I plug in 10 for my x because my input is 10 into my rule. 2 times 10 is 20. Left with 20 plus 1, 21. Y is 21. I plugged it in. So hopefully you got 1 point here and 1 point here. 2 points each. 2, 4, 6 points. Alright, so this is the extra piece of information I want to look at with these. When I find these here, they're not giving me a rule. Well, I have to know what my rule is. How does it change every time? And there's a quick thing that I do anytime I do these. Once again, I don't use the answer key in the book. I take an assignment, I have a blank book, and I do the work in it. And I make sure I get to the answers. Keeps it fresh in my mind. It helps me to realize what kind of steps I will need to explain to you. And when I was working through this, I thought I have a rule or a process that I do every time, and I thought I would share it with you, so hopefully it'll make it a little bit easier. So the first thing I do when I have this type of problem, I look at my first 2. And when I see that I'm going from a smaller number to a larger number, then I'm always going to try multiplication. Now, about 10% of the time, and maybe not even that much of the time, they try to trick you, and they actually do addition. And you may remember that when we did our ratio charts, that some of them were addition, we were increasing by 3, or increasing by odd numbers. We had a couple of those. I was adding 3, then 5, then 7, then 9. So when I look at this, I automatically want to try multiplication. I want to figure out what I'm multiplying by. Some of you will look at that and say, well, I know what I'm multiplying by. But we're going to show how we can prove it. So if I'm going to try multiplication, I don't know what the number is that I'm multiplying by. But I know it's always with the x, because the x is my input. The x is always my independent variable where the work is being done. So I said I'm going to multiply because I'm going from smaller to bigger, so I'm going to show x times something. And I generally put a number, I don't know, it doesn't matter what I put. But I know it's going to be equal to y, which is my output, my dependent variable. So if I plug in the information that I have, well, it tells me that 16, my output, is equal to my input of 8 times some number. How do I do that? Opposite function on the opposite side. So I'm going to, instead of multiplying by 8, divide by 8. And what do? I cross it out. Cancels. Then I go to the other side and divide by 8. 16 divided by 8 is what? It's 2, right? So I know the multiplication that I'm doing is multiplying by 2. But I check it just to make sure. I have a hypothesis. I want to test it and make sure I get to the right answer. If I take and plug in that information then, and I say, well, 18 is going to be equal to my 9 multiplied by a number, and I know that that number has to be by itself, I divide, which is the opposite function, cancels out, and I do it on the opposite side, and 18 divided by 9 is indeed 2. So yeah, I'm going to use multiplication of 2. So I have to look at what now the problem's asking me to do. It's asking me to write an equation. Without an equation, I'm missing a point. There's no reason to miss a point and have to redo my work if I read my directions. Read the directions. Read the directions. Think about the directions. All of the directions. If I write my equation then, I'm saying that y, my output, is dependent on my independent variable. What's going inside my input times 2. So I write down for my first point my equation y is equal to x times 2. And then I have to solve if my input is 10. So if my input is 10, it says find the unknown value, then I just use that and I plug it in. Y is equal to 10 times 2. Well, 10 times 2 is what? 10 times 2 is 20. So if my input is 10, my output is 20? Yep, because we said that's my rule. So I know that my question mark, my missing number, is 20. I want you to try 4 on your own and then come back. Alright, so hopefully you tried it. And here's what I want you to see. I said I always look at the first boxes, and if I'm going from smaller to bigger, I multiply. So I was hoping that when you looked at your first boxes, you saw that I'm going from bigger to smaller, and you thought, well, he multiplied before, so I would divide. When I'm looking at those, and I'm trying to figure out what the rule is, and I see that I'm going from a larger to a smaller, I always try division. About 10% of the time they're going to do a subtraction on you, but very few and far between. If the division doesn't work, which 90% of the time it will, then try the subtraction. But look what happens. If I say, well, I'm going to divide, and therefore I'm going to have y is equal to, my output is equal to, my input of x divided by some missing number, and I plug in the information that I'm given, I know that 5 is equal to 10 divided by n. Now wait a minute. We haven't done a single problem like that in all of the time that we've done opposite function on the opposite side. And you're right, we haven't. So, understand in 7th grade you will, 8th grade you will, high school you will. So I'm going to introduce this to you real quick, and it's not difficult. It just means I'm going to do the opposite function on the opposite side 2 times. And it's not a 2-step math problem, it's just that I have to get in by itself to where it's not a negative or it's not a dividing with. I don't know what to do there. But I know that I can get it on the other side if I just multiply because I'm dividing. So if I do the opposite function and I multiply and it cancels out there, and then I do it on the opposite side, I end up with n times 5. Do I know how to do that? Yeah, that's what we have been doing. I've had my variable multiplied by a coefficient equal to an answer. That's where I go from there. So it's just one extra step in realizing I can't do it with the n on the bottom as a divisor or denominator in fraction form. So if I go from this step, I'm comfortable. I know opposite function on the opposite side. I'm multiplying my n by my 5, so I'm going to divide the opposite function, cancels out, divide on the opposite side, and 10 times 5 gives me that n is equal to 2. Well, if n is equal to 2, my missing number, then my rule, my equation that I have to write down would be that y is equal to my input of x divided by 2. And if that's the case, and I find my missing answer, then hopefully you found, by plugging your information in, that 40, my input of x, divided by 2 tells me that my missing value, my final output, is going to be 20. So this is not a difficult lesson. It's not designed to be a difficult lesson, but neither was yesterday's. If you're just open to learning new terms and looking at things a little differently, once again, ratio boxes, we have done, I think it was chapter 3, it may have been chapter 4, but I know it's been several months ago, and definitely way before Christmas. Then we know how to do this. If we can do the opposite function on the opposite side, which we've done consistently for the past 3 weeks, but I also introduced you to during the geometry section before Christmas, then I got this. If we just stop and think for a moment, think, we'll be fine, because we got this. So what I want you to do is realize that when I'm doing this, I have to read so I can get all my points. I have to show work so I can get all my points. If this is my answer, I will not get a good grade. Because I can get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 answers, but I've missed 12 points of showing work. Actually, it's 10 points of showing work. But you get my meaning. We've got to show work. We've got to show how we're getting to those answers in order to get a good grade. You know, Mrs. Reiner's poster, I forget exactly how it's worded, but it basically says, if it's worth doing, you do it right the first time. Because who really has time to do it a second time? Because those of you that are having to rework and rework and rework because we rushed through something, or we're having to work and work and work because we didn't do it the first time, you're just putting yourself behind. Because I don't stop teaching. I only get you for 180 days, and I only have about 12 weeks left of school. About 11 and a half to get everything done that I need you to have to be successful 7th graders, to be successful in junior high. I can't stop. So for every lesson that you're missing or you have to rework, and you add another lesson to it, your assignment list goes from to here, and then here, and then here. You got to get caught up. You got to do your work. You have to follow along and do it right the first time. Stop rushing through and trying to take shortcuts. You can be successful, and you can all have an A in my math class if you just simply do the steps that I asked and take the time to do it right the first time. As you're doing tonight's assignment. If you have any questions while doing it, and you've watched the video and taken notes, please come and ask. I'm here to help you. I want you to be successful. This is not difficult.